Hello students, in today's video I am going to discuss the concept of double integration, and this will be the first part in the series of double integration. So students, basically what do we mean by double integration? It is double integration of this particular function fxy into dA, or you may write it like double integration of this fxy dx dy, or there might be one more way to write it, double integration fxy dy dx. Basically students, I will be telling you two ways to deal with the double integration. So if I will talk about the first method, in this first method, in order to evaluate this double integration, I am considering that limit of x is constant, and that is suppose a to b, and limit of y is variable, that is suppose y1 to y2. So what is our consideration? That limit of x is constant, limit of x is constant, and limit of y is variable, So how to deal with this double integration? So first of all, we will deal with the variable limit. In order to deal with the variable limit first, I will, inside the parenthesis, I will collect the limit of y, that is y1 to y2, of what? Of the function fxy, and since it is the limit of y, so dy, and then this limit of x a to b, and then it is dx. So this is a way of dealing with the double integration when if x limit is constant and if y limit is variable. Now what is the second method? What is the second method to deal with the concept of double integration? In order to find this double integration fxy, now the consideration is like limit of x is variable, that is limit of x is from x1 to x2, and limit of y is constant, that is from c to d. So our consideration here is limit of x is variable and limit of y is constant. So again the funda is same. We will be first dealing with the variable limit, and limit of x is variable, so inside the parenthesis we will collect this data x1 to x2 of fxy, and this is the limit of x, so dx, and then limit of y, that is c to d and dy. So this is the second way. And just one more funda is here. Whenever we are dealing with this variable limit with respect to y, inside this bracket x will be treated like a constant term, and whenever we are dealing with this variable limit x and integration is with respect to x, so inside this bracket limit of, y will be constant, y will be treated like constant. So these are the two ways to deal with the double integration. Now I am going to discuss here only one question, and with the help of that particular question the whole concept of double integration I will try to clear, and basically which is based upon these two formula, one of these two formula. So now students, what is that question? So let me write that question here. So question is like evaluate double integration, and limit is from 0 to 1, and here 0 to x, and x square plus y square dA. Now students, first of all we should identify that which is the limit of x and which is the limit of y. The students, here this limit is depending upon x, so this is the limit of y. So what is the limit of y? Limit of y is from 0 to x, and if this is the limit of y, so what is this? This is the limit of x, and limit of x is from 0 to 1. So what is our observation here? Our observation here is like limit of x is a constant limit, limit of x is constant and limit of y is variable. Limit of y is variable, and I have already told in this video that we will first deal with the variable limit. How? Inside the bracket I will be collecting the data of y. I mean to say limit of y is from 0 to x, and then function x square plus y square, and this is the limit of y, and then limit of x, that is 0 to 1 and dx. And this thing is also cleared by me, like with respect to y, inside this particular bracket x will be treated like a constant term. So now I am going to integrate this particular term with respect to y. So since x is constant inside this bracket, so we will be getting x square y and plus y cube by 3, and just apply this limit 0 to x, and rest is the same 0 to 1 dx. So what it would be like? It is just like upper limit we will apply, so it would be x cube and plus x cube by 3, and application of lower limit will not make any sense because it will only create 0, and it is 0 to 1 and then dx. Ultimately it is 0 to 1 4x cube by 3 and then dx. So, or I can write it 4 by 3 0 to 1 x cube dx, or it is 4 by 3 and it is like integration x to the power 4 by 4 0 to 1, or ultimately it is 1 by 3 x to the power 4 0 to 1, or 1 by 3 and into 1 minus 0, that is 1 by 3. Since 1 by 3, yeah, that is the final answer. So this is the value of this double integration, and which we have obtained equal to 1 by 3. So students, I hope that in this particular video some basics of double integration are now clear to all of you. So thank you so much for watching this video.